Okay, guys, I think we can start today's session. Okay, so I think people will join maybe after some time. In the meantime, I will be like talking about what are the current chapter that we are going to discuss and what are the topic that we have uh, discussed last class, and then the topic that we are going to discuss this class. Okay, so we are still talking about the rows TF. We have already discussed about the TF last, in the rows 1 session. And in last class, we have been talking about the importance of TF in robotics, and also like what are the things that we can do using TF. Okay, and we started with this page. I hope you remember this. Maybe I can share the link. We started with this, and then we have seen an example of TF using TurtleSim. Okay, so we have seen the demo only the demo part, and then we also seen some of the useful TF2 tools. Okay, so if you remember, we have worked with the view frames. Okay, which is basically give you the PDF file of the current TF. Basically, the TF is a tree. TF is actually a tree. So it will give you a document which is having the TF tree, which is very useful while debugging big application, because sometime what happening is that the TF connection, meaning this TF may be publishing by some nodes. Okay, so imagine one node is not publishing the TF. Okay, so it can break the TF tree sometime. Okay, so you can debug these things using ViewFrame tool. Okay, yes, and we also check the TF2 echo, which is again helpful. We can simply print the transformation between two frames. Okay, using TF2 echo. Okay, and also we have visualized the TF in Avis, which is a good tool to visualize the TF, so that you can see where the TF is moving. Like in case of the turtle TF demo, basically we were been moving one turtle using command velocity, using the Teleo. And so when you move the turtle, what happening is that the turtle 2 is also following it. Okay, so that can be visualized in Arvis. The TF frames can be visualized. So these are the things that we have discussed last class. And also we started with the static broadcaster. Basically, static broadcaster means like it will be broadcasting, or like broadcasting means publishing TF. Okay, publishing TF statically, meaning there is no change in that TF. I will say an example for a static TF. Imagine you have a robotic arm. Okay, and you have mounted a camera on the top of the arm. Okay, top of the arm means not in the gripper, but maybe on the top of the top of the room with some fittings, and the camera is not moving. Okay, so in that case, the transformation from the robot to the camera, you know the translation and rotation of that fixing of the camera. It will not change as well. So you can simply publish a static transform, meaning it will not change. It's a constant always. So we have seen some static transform example using the tool. using this command. I hope you remember it. Meaning, if you want to publish a static transform, you can do it in two ways. Okay. The first way is, the quickest way is, you can simply use the existing node to publish a static transform, which is very convenient, so that you can simply include this node in your launch file, and then you can run that. Okay, so this is an example that we have discussed last class. Basically, in the TF2 ROS package, okay, that is the package which is having the TF2 tools, TF2 ROS tools. There is a node called static transform publisher, which is already there in ROS. Okay, and along with the static transform publisher node, if you give the values like x, y, is z, that is a translation, and qx, qy, qz, qw, okay, that is the orientation in quaternion. And also you have to mention the frame ID, okay, frame ID and child frame. Frame ID means maybe with respect to a frame. So in our case, maybe if it is a robotic arm, maybe we can say it like a base link, okay, and child frame, maybe we can say it's a camera frame, because camera is the frame that we need to publish. Okay, so if you do this, then a new frame will be added, okay, with respect to the frame ID. Okay, and if you want to include it in the launch file, these are the basic launch file description in ROS 2. Like, there is a function called generate launch description. So you have to write this, or you have to define this function and return a list of nodes basically. So here what we are doing is, like, we are starting this node. Which node? The static transform. So the syntax is like node inside this. This is actually a class. Node is actually a class. So you can mention the package name, then executable name, and the argument. Okay. So if you mention this, then you can create a new static transform. Okay, so by writing or including this node on your launch file, you can able to publish the static transform. This is the easiest method to publish a static transform. The second method is to write a program basically. Okay, so here they demonstrated using a Python node, okay, Python ROS node. So there are some Python TF2 ROS API which will help you to publish the static transform. Okay, so this is actually the node, and I can first demonstrate the node. So basically the node, you can download it from here. The source code you can download from here. So basically what they did was, in order to run a node, in order to run a Python node, basically we can either simply run using Python space the Python file. Otherwise, the better practice is obviously creating a package. So after creating a package, you can put the Python ROS code inside it. Okay, so here what they are doing is they create a package. Okay, so I have created that package here. Just a second, inside the ROS 2 workspace, in which we are keeping all the packages related to the course. So you can see the learning, where is that? I think it's an example. Oh, okay. I created in a different. Okay. Maybe I can do it now. Create in a different version. Okay. So in the ROS 2 workspace, inside the SRC, you can simply create this package. Okay, so you can just copy paste. So here you can see the package type is Amen Python, meaning you are going to work with the Python script. Okay, and the package name is learning tf2py. So you can simply copy paste it and then execute inside the src. Okay, so basically you created the learning tf2 Python package, which is having this much of files. And then what you have to do is you have to download this code. Okay, download means like if you just copy paste this command in the terminal, it will be automatically download the code. It's basically using a command called wget. Wget will be downloading the file from this link. Okay, so I'm just going inside this folder. So this is the folder where we are keeping the nodes. So if it is a Python ROS2 package, there will be a folder with the same name as the package. So you can keep the nodes here, and here is the Python code that we are talking about, which is mentioned here as well. Okay, and the explanation is also given here, but I can give you a short explanation quickly, and then we can execute it. So in order to publish a static transform from your Python code, ROS2 actually giving a class called static transform broadcaster. Okay, so here if you check, there is a class called static frame publisher. Okay, which is actually a custom class to publish a static, to demonstrate the static transform publishing or broadcasting. Okay, so here the main class that we have to check is that the static transform broadcaster. Okay, this is a class in which we have to create an object. Okay, and then using that class you can publish or you can send the transform. Okay, so the TF static broadcaster, after creating the TF static broadcaster, it will call this function, and then the TF is basically transform. I mean, it's basically having timestamps and then the transformation. Okay, so the TF message is having basically having the translation, rotation, and the timestamp. So that is actually available in the geometry messages package. Okay, so we need the transform stamped messages in order to publish the transform in the TF topic. So we have imported the transform stamp. So in order to send a static transform, first you have to create a instance of the transform stamped message. I think while working with the ROS1, like in order to publish a specific ROS message, first we have to create an instance of it, right? And after creating the instance, you can fill it. Okay, the ROS message is basically kind of a struct. Okay, in which we can fill the desired field. Okay, so in case of transform stamp, there are many fields that we have to fill up. So one is the stamp, that is a timestamp. So we are filling the current timestamp. Okay, and so if you want to check about the transform stamped message, you can simply Google it and you can find the things inside the transform stamped message. So there is a header, there is a child frame, there is a transform. Okay, transform is another message. So these things we have to fill it up. So this function called make transform is basically filling that thing. So it is filling the frame ID, then the child frame. So child frame, it's publishing as transform 1. So basically it will be the name of the, I think the transform 1 means, let me see what is happening. Okay, I think we can mention the frame name. Okay, so that is the transform 1. So you can see here, we are assigning the translation value, then we are assigning the rotation value. So here you can also see a function, okay, which is very useful to us. It's basically converting quaternion from Euler angle, like from xyz or roll pitch O, it's converting to quaternion. Okay, so this is a function you can see here. So like we can even use this function in your code. There is a custom API as well, but if you want to use a function, I mean defined function, you can use it. So using that function, we are converting the roll pitch O to quaternion, and then using the static broadcaster that we have created, we are sending the transform. Okay, so inside the TF static broadcaster, there is a function called send transform, and send transform will be accepting a transform stamped message. So these are the steps that we have to mention. And in order to run this code, you can see here we have to mention this much of command line argument. Okay, after it's like rows to run learning TF2 py, then static turtle TF2 broadcast, which is the name of the node, then child frame name you have to mention, then xyz roll pitch you have to mention. Okay, all this you have to mention, and you can run it. Okay, maybe I can explain it after running it, so you will get an idea. So they also mention how to update the package that we have created. So basically you have to, like, if you want to, this is not mandatory, like you can change the credentials of the package in the package.xml, like this one. You can change the description, maintainer, license, all this you can change. And you can also add these dependencies, because these all are the dependency for our code. So in the package, again going to the package.xml, you can simply add these things. So the execute, when you execute a node from this package, it will be depending on these packages. That is what I mean by exec depend. Then this is the line where we have to add in the setup.py. Like I think I have explained it before, but I can show you again. Like this is a setup.py. This is an important script, Python script, in which you can mention most of the stuff about the package. Okay, so if you want to mention about a node that you have mentioned, I mean put it in your rows2 package, you can add like this. So this means, like, inside the package called learning tf2py that we have created, there is a node, or there is a rows code called static turtle tf2 broadcaster, which is what we have downloaded here. Okay, and inside that there is a main function. Okay, main function, I think you already seen the main function is here. Okay, so in order to call the main function, what you have to run is static turtle tf2 broadcaster. Okay, I will show you how to do that. Okay, so in order to run the main function, if you call rows2 run learning tf2py space static turtle tf2 broadcaster, then it will be running the node. So that is what this line says. Okay, after doing that, you can maybe install the dependencies using row step. That is not needed for now, but after setting that, after doing this modification, you can go to the workspace path, which is rows to workspace. You can either do call con build, or you can selectively build a package. So here you can see the callcon build package select learning TF2PY. This means it is going to build the specific package, which is the learning TF2PY. Okay, so we have built the package, and one important stuff, you have to check whether your workspace is in the bash RC, which is very important. So you can see here the rows to workspace install setup.bash is already in the .bash RC. So we are done with it. So now you can run the script. Okay, run the script. So this is what the thing. What I'm doing is I'm running the turtle sim. After running this demo, I will explain it in detail. So I'm running the turtle sim here. So this demonstration is about the static transform. Okay, static transform using a Python code. Okay, and you can also do this using C++, which is just below that, but the concept is same, only the lines of code. If you just go through it, you will get the same result, but with a different programming language actually. So here I have started the node that we have created. That will be, I mean, our expectation is it will be broadcasting the static transform, and then we will be checking a topic called TF static. Okay, so in the last class I already mentioned there are two topics for TF. One is /TF, which is publishing the dynamic transformation, that is like the transformation that is changing over the time. But there is another topic which is TF static, in which will not change with time, because the translation, everything will not change. Okay, so see, our broadcaster basically that we have created, you can see this is a child frame. Okay, and this is X, this is Y, and this is Z. This is role pitio. Okay, so if you run it again, you can see the child frame here is my static turtle, and frame ID is world, which is, I think we already mentioned that in the code. Okay, here you can see the frame ID with respect to the world, we are publishing it, and the translation, everything is here. And you can visualize the same in RViz. So in RViz you can see here, just put the global options as fixed frame, and then just add the TF. Okay, so adding the TF, yeah, and if you just click on here, you can see the show names, and then this is what it looks like. It's static transform. Okay, it will not change over time. And I can show you another thing interestingly. So this is static transform, right? I already mentioned. So instead of world, okay, world is the global frame that I'm talking about. If we change to some other stuff, then I think in the first demo we have demonstrated that. Like if you mention turtle1, then it will be going along with the turtle1. Maybe I can show you the same, so you will get an understanding. Okay, so I'm simply running the TF demo that we have seen last class. Okay, running TF2 demo. So it's basically creating two turtle, and then one turtle, the turtle 2 is following it. Okay, so what I'm doing is I'm just modifying our static TF script, and if you check the RVs, just changing to world and adding the TF once, yeah, TF. Okay, yeah. You can see here, show the name. Okay, so here the turtle 1 and turtle 2 is here. Okay, and if you move the turtle, okay, I'm just using the teleo operation, star rows to run, turtle sim, turtle teleo. Okay, and you can able to see the turtle is moving. I mean, I'm moving the first turtle using the teleo, and it is following, and on the back side you can see the TF is also moving near to the turtle. Okay, that was the intended. So I'm just using moving the turtle 1 and the turtle 2 is moving. Okay, so imagine if you want to attach a static transform. Okay, static transform means like we have three transform, right? We have world, which is a fixed frame, and we have two other frame, which is turtle 1 and turtle 2. Okay, if I want to attach a transform on turtle 1, what I need to do is, instead of this thing, I'm just changing to turtle 1. Okay, turtle 1. So I'm going to attach a static transform on turtle 1. Okay, so you can see what is happening. Basically I'm just doing the callcon build, because after each change you have to do the callcon build, otherwise you have to build it using Symlink. Currently I'm just doing the callcon build, and after that I will be running the node again. 1 second, I think it is taking more time. Maybe I can selectively build, it will take time, I guess. Just a second. Yeah, okay. Selective building may be better, I will say. Maybe I can simply close it, and then I just press Ctrl C to abort the entire building, and then just build the selective package. Okay, yeah, now I'm running the node that we have created or we have downloaded. So you can see the result in the RVs. See, on turtle 1 there is a new transform got created, and if we move the turtle 1, it's moving along with it, because with respect to the turtle 1, this thing is static. Okay, there is no change in that transformation. Got it? So this is the application that we are using the static transform. You can either include in the launch file as a node, or you can publish the static transform from the program. Okay, so this is a simple demonstration to add a static transform from a program and from a tool. Okay, so let me know if you have any question regarding the static transform. I mean, I think you got the idea, but regarding the concept, I mean the implementation, basically we are using the static transform broadcaster, which is given by the package tf2 rows. Okay, so there is a class called static transform broadcaster. We can simply import that, and then you can use that static transform broadcaster object.
Cristian,
Yeah, tell me.
una consulta, porfa.
Yeah, tell me. Hello. Yeah, do you have any questions? Do you have any question? Can you mute the mic if you don't have any question? I think. I don't know if he's listening or something. Heidi, do you have any question?
I have a question. I think so. What is the difference like when we use a robot state publisher?
Yeah. So yeah. So the one second. Yeah. So in robot state publisher, I mean, I think I can start from the joint state publisher. The joint state publisher publishes the joins of the URDF, and that is actually subscribed by the robot state publisher, and using that joint state value, it is publishing the TF, the robot state publishing the TF. Okay, so the difference is that the joint state will be always changing. So it will be the robot state publisher basically publishing the TF to the TF topic. Okay, but some if for example in your URDF or something, if there is any static fixed joins or something, then the robot state publisher is publishing that static into the static TF static topic. So robot state publisher is the main node which is doing the transformation, I mean publishing the TF. But here if we want to, in some situation, maybe you may not have the joint state values or something, so you have to directly publish the TF from your program. So that's where the static transform, all these are coming. Like maybe while working with the real hardware or something, if you want to publish a static transform, at that time this kind of APIs will be helping. And also the normal transformation, like this is mostly helpful while working with the real hardware, because we will have the URDF, but still maybe you have to publish some extra transform like statically. So in that situation you have to publish it. So like while working with different application, we may have to use this kind of APIs. Maybe I can say an example. While working with some application, industrial robotics application, we have to publish some static transform, like which is basically cameras which is not moving at all. So we have used the static transform to publish the camera frame. So once we get some data from the camera, we can use this static transform because the static transforms are also in the TF tree. So you can compute the camera transform using it. So like I will say like the robot state publisher doing the same thing. It is also using the TF APIs to do the same. But if you want to do the TF publishing like in a custom program or something, you have to use it. Hari.
Okay. One more question is it important to use the setup.py every time?
Okay. So the setup.py is used in a Python ROS2 package. Okay. So you have to do the customization once, then you don't need to touch it. Like when you add something, when you add some launch file, when you add some script like Python script or something, then you have to edit it. So these setup.py is creating automatically actually. It's not created by me. It's all created. Like if you are using the amend Python, like I'm not sure you have seen the command to create the package. So here we can mention what type of build type we need, amend Python or amend CMake. Amend CMake basically for C++ package. Amend Python is for the Python. So if you want to mix it, maybe you can use the setup.py for C++ and Python, I guess. So there is an option. And in CMake, we have to mention the C++ file. So basically, the setup.py, we have to edit it when we add a new script. So it is mandatory, actually. Yeah.
Thank you.
Okay. Okay. So yes. So that is about the static transform, which is useful while working on the real robots, and also to publish the TF in some application, simulation application as well. So next topic is so we have talked about the static broadcaster. Next is normal broadcaster, I mean normal TF broadcaster. So this is a C++ implementation that you can check. Here also, like we are doing the same, like we are using the static transform broadcaster class, and we are populating the transform stamped message and publishing it. Okay. So here is the TF broadcaster. Okay. So Hari already mentioned about the robot state publisher. It's basically using the transform broadcaster API. Okay. So in this example, what they did was they just publish a transformation of a turtle. Okay. A turtle. So I will explain it so you will get an idea. So the concept is very simple. The concept is that instead of listening to the joint position, this code basically subscribe to the turtle position. Okay, so the turtle sim is actually giving a topic of the turtle position. Okay, so this program, okay, this Python code basically subscribe to the turtle position. Okay, and after getting the turtle position, it's converting to transformation. Okay, and it's broadcasting the turtle TF. So first I can show you, because these examples are actually the implementation of the TF2 project that we have seen first. We have seen the turtle is following another turtle, right? So this broadcaster is actually a part of that application. Okay, this broadcaster is publishing the transform of each turtle. Okay, each turtle. So here maybe what you can do is if you have the package ready, then as I have shown you the last time, this is where we have to keep the node. So just open the terminal and then download the script. Okay, you can either write it or you can download it somewhere, and this is a code. Okay, this is a code, and based on the parameter that you are giving, okay, it will be publishing the TF. I will show you that. So we have added the node. Okay, we have added the node to our package, and then what are the things that we have to do? We have to edit the setup.py, and also we have to add the package.xml. So here in this example, maybe I can share the same. In this example, they also shows the launch file in order to run these two things at the same time. Maybe I can show you step by step. That will be better. Yeah. So this is the entry point that we have to add after adding the node. We have to edit the setup.py and add the entry point. Okay. So this is the entry point that we have to add. Entry point means we have added a script, new script, which is turtle TF2 broadcaster. Okay, and that is what we have added here. Package name dot turtle TF2 broadcaster, which is the node name or the script name and the main. Okay, so we have added that, and if you plan to run a launch file inside the package, then you have to add some dependency in the package.xml. So the launch package and launch rows package is the exec dependency. So you can simply add that in the package.xml. Okay, so these are the two packages that we require to launch a launch file, and you can simply create a folder called launch, and then you can copy paste this launch file. Okay, so this launch file is basically starting the turtle sim and also the TF2 broadcaster that we have created. So what I'm going to do is I'm just creating the launch file. What was the name of the launch file? 1 second. The name of the launch file is nano. 1 second. Okay, so this is the launch file and we need to copy the stuff into it. So we got a launch file, and the last step is that we have to add one more line, which is very important, like that is again in the setup.py. So in the data file we have to add like this line. So this line says there is a folder called launch folder, and you have to copy the files inside that into the install folder. Okay, and you have to add these two header files as well, modules as well. So what are the things that we have added in the setup.py? We have added the entry point of the new script, and also we have added this line basically for copying or installing all the launch file into the install folder. In the build, you have the build, install and log folder, right? So, and in order to work with the OS module, we have to import the OS as well. So these are the changes that we have to do for putting the script, and I think we already done that. And after that, basically you can build the package using Qualcomm build. You can use this command, Qualcomm build package select. Seems like it's built, and now you can use the launch file command to start it. Let's see it's working or not. Yes, so it seems like it is working. Okay, so I will explain it from the beginning. Okay, so basically what we have seen is we have a Python script which publishes the transform of the turtle. Okay, so if you want to publish the transform of turtle1, you can select that. If you want to publish the transform of turtle2, you can select that. Okay, that is this program. Okay, and what we have done was we have written a launch file. Okay, and in the launch file, when you start, what is the purpose of launch file? In order to run multiple nodes at the same time, right? So in this launch file, we have started the turtle sim. Okay, then only we will get the pose of the turtle, and then we are starting the node that we have created. Okay, so the node name is turtle TF2 broadcaster, and you have to pass the parameter like this. So if the parameter name is turtle name, and if you set the turtle name to turtle1, then we are trying to broadcast the TF of turtle1. Okay, if we add again for turtle2, we will get the two TF. Maybe we can simply demonstrate, then only you will get it. It's very simple, but when I'm explaining it, I think it feels complicated. Okay, so what I'm doing is I'm just moving the turtle. Okay, I'm just simply moving it. Okay, there is nothing new, but if I'm taking the RVs and if I'm visualizing the TF, you can see the transform of turtle1. Okay, so this is the purpose. Like when you move the turtle in the turtle sim, the transform of the turtle is getting published. Okay, so this was the demo that we already seen in the TF turtle demo. So this was the main thing. So I can explain the code. The code basically subscribing to the pose of the turtle. Okay, so this is the code. So you don't need to worry about the size of the code, but mainly I think understand the logic, and other thing I think you can modify. Like in this code, basically you can see a class called frame publisher. Okay, first you can start with the main. Okay, so here the mandatory stuff is initializing the RCLPY, and then you can see we are creating an object of the frame publisher. Okay, and and then we are just spinning it. Okay, so the frame publisher is the node class. Okay, that is the node class, and inside the node class you can expect everything. Okay, so inside the node, what happening is that we are creating a subscriber. Okay, we are creating a subscriber. So what is the subscriber? The subscriber subscribing to the pose of the turtle. Okay, so if you give the name of the turtle, then it will be like, for example, it will be subscribing to turtle one pose, that topic. Okay, so whenever a pose comes, then that pose, whenever the pose comes, it will be calling this callback, and that callback will be publishing the TF or broadcasting the TF. Okay, so that is what this program is about. Okay, so like we are getting the pose of the robot, and then after getting the pose, in the callback, like when you subscribe, there should be a callback, right? So that callback, inside that callback, we are doing the broadcasting of the TF. Okay, so the broadcasting of the TF basically having, I mean, it's almost the same that we have seen in the static broadcaster. You can see here we are using a class called transform broadcaster. Okay, which is the main class that we are using, and instead of static transform broadcaster, we are using transform broadcaster. Okay, rest of the things are the same. So here for the translation value, we are reading the position value from the turtle. Okay, we are getting the position of the turtle, right? Turtle from this subscribing of the pose value. So by subscribing the pose value, we are simply getting the XY and also the theta. Okay, so XY is directly feeding to the translation, and the theta value is converting into quaternion. Okay, so that conversion is happening here, and then it is sending the transform. Okay, so this is what happening in the TF2 broadcaster. Okay, and next I think we can see the listening of the TF. So that is showing here, writing a listener. So here what we are doing is we are listening to the transform, and then listening to the transform of turtle 1 and turtle 2, and then sending the command to the turtle to move. I think this is, I mean, take some more time to explain. Maybe tomorrow I think we will have classes, so I will be explaining that, and then after that we can start with the URDF. Okay, like we did for ROS 1, we can see the URDF, the basic URDF from scratch, we can check. Okay, so do you have any question, like Hari, or do you have any questions regarding the transform broadcaster or static broadcaster, if you have any?
This example is quite similar to the ROS one.
Yeah. It's
TF that.
Yeah, it's the same example, just converted into ROS 2, and the what the listener and broadcaster example. No, these two examples actually the implementation of the TF2 example that we have seen the turtle scene. I mean, we have seen that follower application, right? Turtle follower. I mean, one turtle is following another. So that implementation is actually demonstrating with the example. So the broadcaster will be broadcasting the TF of both the turtle, and listener will be listening to this transform and then finding the error between these two turtle and then sending the appropriate velocity command. So the first example that we have seen, which is this one, okay, this demo, the implementation of that demo is that is explained here as broadcaster and listener. Okay. So I think we can conclude for today. So tomorrow I think there will be classes. Yeah. So I think that's it, guys, for today. If you have any questions, let me know. Like, you can put it in Discord. I will be updating the video in the GitHub maybe after the 2 sessions. Okay, guys, thanks for attending. See you tomorrow. Bye.